Another Falcon 9 second stage fails to deorbit, the second such incident in about a year. Jupiter is smaller than we thought, and it turns out size does matter. NASA's Artemis II gets delayed until March following a pre-launch test with more hydrogen leaks, and Vulcan finally arrives at Vandenberg. As always, we've got all that and more coming up this week in Spaceflight. Once again, a Falcon 9 second stage has failed to deorbit. This occurred on the latest Falcon 9 launch, Starlink Group 1732, which launched from Vandenberg earlier this week on February 2nd. Its primary mission of launching the satellites and deploying them into the planned orbit occurred without issue, and normally the second stage then performs another burn after satellite deployment to re-enter Earth's atmosphere and not become orbital debris. In the case of this mission, the re-entry area was supposed to be in the Pacific Ocean east of New Zealand. However, that maneuver failed to occur on this mission, meaning that the Falcon 9 second stage did not deorbit as planned. SpaceX released a statement later in the day saying that, quote, "The second stage experienced an off-nominal condition during preparation for the deorbit burn. The vehicle then performed as designed to successfully passivate the stage." In this case, passivating the stage refers to venting out the remaining propellant and pressurization fluid, as well as draining the battery so the second stage becomes inert, a process often used in the space industry to minimize the chances of energetic events happening after the end of a mission. The US Space Force ended up cataloging the second stage in a 110 by 241 kilometer orbit just a few hours after launch, and with such a low orbit, it ended up re-entering less than 12 hours after launch. Now, this isn't the first time that something like this has happened. Almost exactly 1 year prior, another second stage from a Starlink mission also failed to deorbit after completing its primary mission. At the time, SpaceX stated that it had been a small liquid oxygen leak that caused the issue. This second stage in particular was notable because its re-entry a couple of weeks later occurred over Poland, and some of its debris was found to have reached the ground. Prior to that, SpaceX also had two second stage issues in 2024, one during ascent, which led to the first in-flight failure of the Falcon 9 since 2015, and another where the second stage deorbited, but it did so in the wrong area. Other Falcon 9 second stage deorbit issues also occurred on at least 5 different Starlink missions between 2020 and 2021, with some of those also leaving debris in populated areas. That said though, these events are rare. It's worth pointing out that while the previous issue happened only a year ago, it was also 165 launches ago. But just because they're rare doesn't mean they should be ignored when they occur, which is why SpaceX has paused its launches for the moment to investigate the issue. The FAA also said in a statement that it's requiring a mishap investigation because of it. Thankfully for SpaceX, this instance was another quick turnaround. Late on Friday, the FAA informed NSF that Falcon 9 had been cleared to return to flight. The fault that doomed Starlink 1732's deorbit burn was described as the Merlin vacuum's failure to ignite prior to the deorbit burn, and that technical and organizational preventative measures have been identified to prevent this from happening again. Now, there must have been some reason why the engine didn't relight, but that information is for SpaceX to release if they ever feel like it. With this authorization, this shouldn't impact the launch of Crew 12, which is planned for next week. That launch will also be the second human spaceflight from Space Launch Complex 40, but it definitely won't be the last. SpaceX confirmed this past week that they're moving all of their Dragon missions over to this launch pad and using Launch Complex 39A mostly for Falcon Heavy and Starship missions. Some Falcon 9 missions may still launch from LC-39A though, especially those that carry payloads that need the ability to load liquid methane and liquid oxygen through the transporter erector, a feature only available at that site. Because of this, SpaceX is now in the process of removing the crew access arm from the LC-39A fixed service structure. Let's just hope that at least they get to save the white room at the end of the arm with all the different signatures from the many crews that have launched from there. NASA's Artemis II mission, which will see the return of human spaceflight back to the moon, is delayed until March, and you can blame hydrogen for that. This week, the agency conducted what's called a wet dress rehearsal ahead of the launch in order to test the rocket and ground systems and to confirm that everything is ready for launch. The countdown started back on January 31st after a 48-hour delay due to weather in Florida. It proceeded largely without issue for the first 35 to 37 hours, as those are usually the hours used to prepare the rocket and ground systems for the more intense part of the count, the propellant load sequence or tanking operations. That sequence often begins around 10 hours prior to liftoff time, and yes, while it was a ground test with no intention to lift off, it was still counting down to a simulated launch. And you'll probably hear me say this a few times over the course of this story, so just keep in mind that this was always meant to be a simulated launch time. According to Artemis II launch director Charlie Blackwell-Thompson, the start time for the start of propellant load was delayed by about 30 minutes due to a late evacuation of the pad, but despite that, it all began just fine. The sequence of loading propellants on the SLS rocket begins with the large orange core stage. This loading first starts at a slow rate in what's referred to as slow fill, and is then followed by fast fill, which is, as it sounds, the load of the propellants at a faster flow into the tanks. The slow fill part of the tanking operations went well, but the problems started when they transitioned into fast fill with the hydrogen, something they'd already seen during the Artemis I campaign.
Got into chill down for both LOX and hydrogen. That went very well. Nothing notable there per the timeline, per the plan. When we got into the LH2 fast fill, which was around 12:29, is when we picked up our first leak in the TSMU in the cavity, which is where the flight and the ground plate come together, and it's that cavity in between. And it's in our 8-inch fill and drain line there. We have a QD that kind of connects those two together. So it was similar, I would say, to some of the signatures that we've seen during Artemis I. Our leak rate was a little bit higher, somewhere in around the, I would say, 12 to 14%. As you know, we went back, we did some testing between Artemis I and Artemis II, and determined that 16% was an appropriate leak limit for LH2 in that cavity, and so that's what we managed to yesterday. So we saw the leak get up around our limit, and we did a stop flow revert, and when we did that, we saw, of course, the leak came down.
To solve the leak issue, the teams implemented the same mechanisms and techniques that they'd learned from Artemis I. At the time, they learned that the leak issue had to do with how the interfaces between the rocket and the ground contract as they get cold due to the hydrogen. This contraction leads to a slight unseating of the connection, and thus a gap that allows hydrogen to leak out. So, a way to solve this involved stopping the flow of hydrogen and letting the interfaces between the vehicle and the ground warm up and reseat, temporarily preventing the leaks and allowing them to resume flow of hydrogen. SLS was eventually fully loaded with propellants, and that allowed the closeout teams to rehearse their activities of loading the crew, but without the actual crew, preparing Orion's cabin, and closing out the hatches to Orion ahead of launch. Due to the hydrogen leaks, these activities were already running behind schedule. On top of that, the closeout crews also had problems sealing the hatches and had to work through those as well, delaying the simulated launch time close to the end of the 4-hour test window. Prior to the test, NASA had planned to perform what they call 2 runs through the terminal count. That is, running through all of the events of the terminal count twice. This would see them holding the count at T-minus 90 seconds for about 3 minutes, resuming the count until T-minus 33 seconds, then recycling back to T-minus 10 minutes and counting down again up to T-minus 30 seconds. Terminal count lasts only 10 minutes, but these are also the most active 10 minutes of the countdown. So while it wasn't necessary to do this hold and recycle test, it was something that would have given them extra practice in case they need to do so during an actual launch. Unfortunately, because they were already running out of time in the window, NASA only had enough time to do 1 run-through. So, once it was ready, SLS finally went into terminal count. And then, the clock stopped once again at T-minus 5 minutes and 15 seconds. The reason? Once again, hydrogen.
Got through our polls, picked up the count, counted through 6 minutes. Of course, the crew access arm comes back at 8. That was a big milestone for us. First time we'd ever done that in terminal count with the ground launch sequencer. So a big win on that. It came back just fine, latched into place just like it's supposed to, and we got down inside the 6 minutes, and that is where we began core stage pressurization. And so as we began that pressurization, we did see that the leak within the cavity came up pretty quick. We did a cutoff, which is a normal safing activity for us. We got into our safing steps. We saw the hydrogen concentration come down, and then later in the evening, we got into our drain operations.
Due to this terminal count not being completed and the recurrence of the hydrogen leaks, NASA decided to call off a launch attempt anytime during the February launch window and instead move their next launch attempt to the March window. The crew, which had been under quarantine for about a week, has since been released until they're due to return 2 weeks away from the next potential launch. Agency officials say that ground teams will be working on the tail service mast umbilical at the pad that caused the hydrogen leaks and will attempt to do another wet dress rehearsal in the coming days. Now, it's possible that you already know a lot of what happened during the wet dress rehearsal if you're a subscriber of the channel. We had a marathon 14-hour-long live stream from right before the tanking operations until shortly after the end of the test. Whenever NASA tries another test, we will be back with even more coverage on this channel, and we'll also be sure to report on it in future episodes of This Week in Spaceflight. So if you're not already following us and staying up to date, be sure to subscribe and activate your notifications so you don't miss out. And if you like our space news coverage, give us a like too. Okay, now we've got a whole bunch of engine testing to talk about, starting with Astra. They're still inching forward towards getting their Rocket 4 ready for flight, and part of that process involves engine testing, involving firing up the engine's combustion chamber to test a new design that both increases production and allows for quicker manufacturing. As you may know, Rocket 4's engines are based on Firefly's Reaver engines. Although these have flown several times on Firefly's Alpha rocket, Astra CEO Chris Kemp hasn't been too kind on their design, so they're now trying to improve them. This week, they fired up a thrust chamber again to find the design's limits. But there's more. They also posted a picture of two of their xenon-powered spacecraft thrusters firing side by side inside of a test chamber. And not gonna lie, that looks right out of science fiction. Speaking of futuristic engines, Stoke Space tested its Zenith engine this week. It may look like a bunch of spaghetti, but this engine is a methane-powered, full-flow staged combustion cycle engine like SpaceX's Raptor. So pretty futuristic indeed. Ultimately, 7 of these engines are going to power the first stage of Stoke's fully reusable Nova rocket, which should start flying this year. Now, we've seen Zenith fire before, but this time they're trying to find its limits. The photo pictured the engine during a test to demonstrate fuel pump suction performance, pushing the turbo machinery to its max. Unfortunately, we didn't get much more than a picture this time, but it still looks great. Of course, methane-powered engines are all the rage nowadays, and India is also developing one for its next generation of rockets. They're still in the early phases and are literally taking baby steps, starting with downscaled components. Recently, the Indian Space Research Organization fired up a subscale thrust chamber, successfully testing it to 56 bar. ISRO built the thing through additive manufacturing, or 3D printing, and they plan to fire it up during further tests to determine the optimal configuration for the engine's propellant injectors. Getting this right is key to engine performance. Continuing with engine parts, the European Space Agency shared some amazing footage of the exploration company testing a new engine igniter, and it has an interesting trick up its sleeve. The exploration company has been working on this project under ESA's Thrust Initiative, short for Technologies for High Thrust Reusable Space Transportation. So what's that special trick and how does it help reusability? Well, this igniter doesn't really contain a heat source like a spark, glow plugs, or torch igniters. Instead, it ignites its propellants using resonance. It works by using a nozzle and chamber with a special shape finely tuned to amplify acoustic waves in the gas. These waves interfere with each other, creating pressure fluctuations and increasing the temperature. Apparently, this raises the temperature so much that the gas ignites, which the exploration company demonstrated to ESA in a test last November. It's a lightweight solution that can be used over and over. Perfect for a reusable engine. Of course, engines aren't their main business. They're building a reusable capsule called Nyx for flying cargo and humans. They recently completed a series of 20 splashdown tests with a quarter-scale model, and looking at the slow-mo footage, this 135-kilogram model created quite the splash. The International Space Station will once again open its doors, or hatches, to private astronauts. This week, the agency announced that it had awarded the 5th private mission to the orbital outpost to Axiom Space. Now, that's not too surprising, as they won the first 4, but there's more to it than you'd think. So let's dive in. NASA and Axiom are currently targeting January of 2027 for this mission, although the ISS's schedule has been very fluid, so it could be later. That same schedule will also dictate the mission length, which is currently set to be up to 14 days. As for who's going to fly, we don't know yet. Axiom first has to propose 4 crew members to NASA and its ISS partners for them to review and confirm the prospective visitors. And only then can the 4 start training with NASA, the international partners, and the launch provider. But who's going to launch the mission? Well, they haven't announced that yet either, but there aren't too many options. Realistically, there's only one. SpaceX, just like the first 4 Axiom missions. For this partnership, Axiom will buy services from NASA to support its crew on the ISS. Meanwhile, NASA plans to buy cargo space on the way back from Axiom to return some scientific samples back to Earth. But Axiom also announced another partnership for this mission. The company will team up with Voyager Technologies to work on payload integration, which is kind of an interesting development as Voyager is actually a competitor to Axiom's space station business. It's one of the companies behind the upcoming Starlab space station. And on the subject of competition, there was another competitor to this fifth private ISS mission. In late 2024, VAST announced that it had signed a contract with SpaceX to launch up to 2 missions to the orbital lab as part of a bid for the 5th and 6th private missions. The company wants to use these missions to gain experience before flying crew to stations and use what they've learned while operating its own Haven space stations. Obviously, they didn't get the contract for Mission 5, but NASA is still finalizing the assignment for the 6th mission. Could that mean that they're working on a contract for VAST? Or will Axiom maintain its monopoly on private ISS missions? I guess we'll have to wait and see. But what do you think? Let us know in the comments. Now let's check in with one of the players in the European Space Agency's European Launcher Challenge, PLD Space. The Spanish company is making strides to get its Miura 5 rocket off the ground, and this week they posted an extensive update to share their progress. Miura 5 is the first orbital vehicle in PLD's Miura family of rockets. Standing nearly 36 meters tall, it'll be able to launch over 1,000 kilograms to low Earth orbit with its 2 kerosene-powered stages. Late last year, PLD showed off the first completed Miura 5 qualification model. This is a complete rocket, but they only plan to use it for testing on the ground. In their recent update, CEO Raul Torres announced that this model is now fully verified, and not just for a single flight, but for reusability. Yep, this rocket is designed with reusability in its DNA. The first stage fuel tank of this qualification model passed over 150 tests, and it'll get to see more as PLD plans to use the same model for Miura 5's Wet Dress Rehearsal, during which they'll load the rocket as if preparing for a flight to test all of the ground systems and procedures, much like NASA just did for Artemis II. And there's even more rocket hardware. They also have the parts for a second qualification model. This will repeat the same tests which PLD wants to do to ensure that the manufacturing process really works and that they didn't just get a good vehicle by accident. Torres hopes that building 2 whole qualification models before getting to the actual flight hardware will reduce issues with their first flight-ready vehicle. Speaking of, the first parts for this flight article are underway, with tank sections for the liquid oxygen and fuel tanks now completed and inspected. The tanks will soon be finished and turned into a full vehicle. Meanwhile, PLD has been testing pretty much any component that it can, subjecting several parts to vibration testing, including the reaction control thrusters and the payload adapter, which was given a good shake with a 600-kilogram payload simulator on top. You really don't want the front of your rocket to fall off early, as Japan's H3 recently demonstrated. PLD is also working on the launch pad's ground support infrastructure, which they plan to test at their site in Teruel, Spain, before moving it halfway around the world to French Guiana, where they're building the launch pad. From the video, they've still got a while to go before this actually becomes a usable launch pad, but there's also still a lot of 2026 left to meet their target of launching this year. Either way, we love updates like these. They really give some great insight into how the company is progressing, and it seems that Miura 5 is coming along really well. Now we'll take a look at some other stories across space, starting with a ship arriving at Vandenberg Space Force Base in California that carried a very special piece of cargo, the very first Vulcan to launch from the West Coast. The ship was, of course, United Launch Alliance's rocket ship, which it uses to ferry rocket parts between its factory in Decatur, Alabama, and its launch sites. On Tuesday, ULA announced that rocket ship had docked at Vandenberg and was offloading the Vulcan stages. From there, the rocket will make its way to Space Launch Complex 3, from where it'll launch. Like Vulcan's Florida launch pad, Slick 41, the pad in California previously supported Atlas V launches, but there's one big difference. Slick 41 still launches the occasional Atlas V, as it's able to host both rockets, whereas Slick 3 saw its last Atlas V launch in November of 2022. ULA has since been converting the pad for Vulcan launches, and the first one of those is finally coming up. Although, we don't have an exact launch date yet. The first launch on the schedule from Vandenberg is set for sometime in the second quarter of this year, and it'll carry a bunch of Tranche 1 tracking satellites for the Space Force's proliferated warfighter space architecture. 6 more Vulcans are currently set to lift off from Vandenberg by the end of the year, all lofting something for the US government. But we'll have to see whether ULA manages to get it all done in time. See, Vulcan's launch cadence hasn't been spectacular. We've had only 3 flights since the first launch just over 2 years ago. But at least it's nice to see that Slick 3 is getting back into the action. German rocket builder Isar Aerospace needs more test facilities for its Spectrum rocket, and it's found them in northern Sweden. This week, the company announced that it's opening a second test site at the S-Range Space Center to support Spectrum development and production. Meanwhile, the company is also working on a new production facility near Munich in Germany, which will enable them to increase the cadence at which they churn out rockets. To make sure that all of these rockets are ready for flight, they also need to be tested, and that's where the new facility at S-Range comes in. The new test site will allow Isar to acceptance test over 30 engines per month and will also subject entire Spectrum stages to their own suite of acceptance tests. Isar expects this new factory space and test site to support the launch cadence that they're aiming for so that they can meet growing demands for launches. Now, you might have known that Isar already has a test site at S-Range. They've used it for the acceptance testing of Spectrum's Aquila engines, including the ones for Flight 2. Onward and Upward, as Isar named this second mission, was originally scheduled for last month, but they scrubbed to deal with a troubled pressurization valve. They've since addressed that issue and now plan to launch Spectrum's second flight during a launch window opening on March 19th. You know, you'd think we'd know our corner of the universe pretty well at this point, but it appears we got Jupiter's size wrong. This week, NASA announced that the largest planet in the solar system is actually smaller and flatter than we thought. Now, before you start imagining Jupiter as a pancake whizzing around the sun, it's not that extreme. But how does one actually determine a planet's size? You can't just walk up with a tape measure. Well, there are a number of different ways to size up a planet, but for Jupiter, scientists used so-called radio occultations. When passing behind Jupiter from Earth's perspective, NASA's Juno spacecraft transmitted a radio signal to the Deep Space Network. Since there's a big planet in between, the signal has to travel through Jupiter's atmosphere, which bends and delays the signal, changing its frequency. Analyzing exactly how this signal distorts can tell us a lot about the conditions in the atmosphere, and using some clever math, scientists can even calculate the planet's dimensions with great precision. NASA previously used this technique with the Pioneer and Voyager missions to perform 6 radio occultation experiments, which were then used to calculate the planet's size. Juno has since been able to provide more data, which helps to refine the measurements. But there was a problem. The measurements were impacted by the planet's atmospheric conditions. Fortunately, the scientists could correct for that, and now the results are in. They found that Jupiter is about 8 kilometers narrower and 24 kilometers flatter than we thought, based on the Pioneer and Voyager measurements. Now, at Jupiter's scale, this isn't all that much. In fact, it's nothing compared to its radius of over 71,000 kilometers at the planet's equator. But it matters a lot to astronomers because it not only helps us to understand our solar system better, but Jupiter is also used as a calibration standard for other gas giants in our solar system and elsewhere. And this small difference could have big implications. This is your weekly space traffic report provided by NextSpaceflight. This week was a rather quiet week in space traffic with just 3 launches. The first of them was from China, carrying the ALSAT-3B Earth observation satellite for the Algerian Space Agency. That launch from China was the 24th and last of January, which was the most active month of January ever. Once again, SpaceX became the most active launch provider with 13 launches during the month, followed by China, which carried out 8 launches. January of this year was also marked by 3 launch failures that took place in a rather short span of time. They were also rare because 2 out of the 3 failures occurred with such established rockets as the Indian PSLV and the Chinese Changzheng 3BE. Unfortunately, February didn't start completely failureless either. As you may recall from earlier in this episode, SpaceX's latest launch, while successfully completing its primary mission, still had an issue with its second stage. This past week, Russia also carried out its first launch of the year with the Soyuz 2.1B from Plesetsk, launching a set of classified payloads for the Russian Ministry of Defense. Next week could be much more active, with launches planned from multiple sites around the world. SpaceX is planning up to 3 launches next week. 2 of them will be Starlink missions, but the third will be Crew 12, the next crew rotation mission to the International Space Station. That launch will also feature the first booster return at the newly built Landing Zone 40, so that means both launch and landing will take place within the same complex. And SpaceX won't be alone when it comes to potential launches from the United States next week. United Launch Alliance is also preparing for the next launch of its Vulcan rocket, which will carry the USSF-87 mission for the U.S. Space Force. That same day, there's also a launch planned for the first batch of Amazon satellites on board the European Ariane 6 rocket. That mission will also be the first launch of the Ariane 6 rocket in its 4-solid rocket booster configuration, the most powerful and most capable yet for the family. Russia is also planning to launch a Proton rocket next week, carrying the Electro-L No. 5 satellite into geosynchronous transfer orbit. This launch had originally been planned for late December, but a software glitch on the second stage forced the rollback of the rocket and a delay of more than 1 month. This will also be the first launch of a Proton rocket in almost 3 years, so as you can see, these are becoming a rarity. And from China, we'll have 2 orbital launches next week. The first one should be this weekend, and could be carrying the secretive Chinese experimental spaceplane that the country has flown on at least 3 prior occasions. A Jielong 3 is also planned to launch next week from a barge off the coast of the city of Haiyang. But all eyes will be on a suborbital launch that could happen next week from the Wenchang Space Launch Site. Preparations have been underway at the spaceport's Launch Complex 301 for the in-flight abort test of the Mengzhou spacecraft. Mengzhou is China's next-generation crew spacecraft, which will replace the current Shenzhou spacecraft in low Earth orbit and will be used for its lunar program. Thus, the success of this test will determine whether China's future human spaceflight programs will continue to progress on time or not, which is something pretty important these days if you think about it. Now, these are the launches that we know may happen in the coming week as of recording, but sometimes a few new ones pop up in the schedule, or some could also delay between now and our next space traffic report. So we always recommend that you go to nextspaceflight.com or download the app on your phone so you can stay up to date with all of the space traffic. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.